Right, let's take a look an example of this given in this given slide. Okay, given a 25 kilogram block is subjected to the force F equal to 100 newtons. Okay, the spring has a stiffness of K. K here is the stiffness of the spring equal to 200 newton per meter, and is unstretched when the block is at A. Okay, the contact surface is smooth. If you see here, I have only one block in which in the first place it is in A position here, and it is kind of attached to a spring to this point. So the length of the spring is actually 0.3 meter towards the center, and it is being subjected to a force of 100 newton. After several distance S here, the block is now being located here. So now if you see, the block is at a new position while the spring is some kind of stretch from this length to this length, while you know that the spring is actually equal, the spring has a stiffness equal to 200 newton per second, 200 newton per meter. Okay, so what do you need to do? Okay, get the information here. They give the contact surface is smooth. What means by smooth here is the surface between the block and this ground is smooth. So means there is no friction. It is frictionless. So means that Fs, we always put that friction force as Fs is actually 0. So you need to draw the free body and kinetic diagrams of the blocks when S equal to 0.4 meter. So here, for example, if we put S here equal to 0.4, so you need to draw the free body diagram and the kinetic diagrams of this block at that position. How to do that? First, you need to define an initial coordinate system. Either it is X, Y, Z, or NT, for example. So you need to define by yourself. You need to decide which type of plane or initial coordinate system that you want to use. Okay, second, draw the block free body diagram showing all external forces. Remember that free body diagram just now is summation of force. Okay, third, draw the block's kinetic diagram, in which kinetic diagram will be the measurement of MA, showing all the initial force vector in the proper direction. Okay, an initial SY frame can be defined as fixed to the ground. Okay, this is the solution. Second, draw the free body diagram of the blocks. How to do that? Okay, you need to consider once the block has moved 0.4 meter, because they mentioned here 0.4 meter S. So what's going to happen there? Okay, I have a block and I also have, this is my block. This is the weight acting on the body, which is W equal to mg. M here is 25 kilogram. So means that 25 times G, and it is always pointing downwards because it is concerned with the gravitational force. Okay, it's mentioned it is subjected to F equal to 100 Newton. Okay, once we have the block is actually laying on the ground, so we have another force. We say this one as neutral force, normal force, sorry. So this is normal force. Why normal? Because normal always pointed 90 degrees from the ground. If you see here, the ground is actually perpendicular in this direction, and this is 90 degree. So it's always pointing opposite to the wake or ground. Right. So where's the spring? Okay, the spring is here. If you see, it is mentioned that F, the K here is actually 200 Newton per meter. So the formula of solving for spring is Fs equal to K times with S. So this is actually F equal to Ks. But what is S here? Okay, S here is they mention that S in terms of delta because there is some kind of changes in terms of displacement. So delta here is actually changes of displacement, or we say in this case is spring deformation. So when S equal to 0.4, the changes in terms of the spring is actually 0.5 minus 0.3, which is equal to 0.2. Where do you get 0.5 here? Okay, 0.5 is actually, when we refer back to this diagram, this is 0.3, while this is 0.4 because they mentioned here 0.4. So if we calculate by using the theorem Pythagoras, 0.4, we have 4, 3, while this one will be 5. So this is going to be 0.5. So you need, so the initial spring's length is actually 0.3, while the final one is 0.5. So we know that the deformation of the spring will be 0.5 minus 0.3, which is equal to 0.2. So once you know the 0.2, technically we know Fs, in which Fs equal to 200, which is, this is K, the spring's constant. Spring constant is the spring stiffness constant, times with the deformation of the spring. So 200 times 0.2, in which it will give you 40. Okay, 40 Newton. Alright, so you know you have solved the free body diagram. So this is also mentioned there is no friction force. Why? Because the contact surface is smooth. Right, so now you need to draw the kinetic diagrams of the blocks. Okay, you know that when the force is acting on this body towards this direction, where is the direction of the motion? It technically will be in this direction. So you know that the acceleration will be pointed towards this direction. So it will be easy for you to determine the direction of the kinetic diagram. So you just put here as this is considered as G, or this is center of mass. So it means that 25 times A. So the block will be moved to the right. The acceleration can be directed to right if the block is speeding up, or to the left if it is slowing down. Okay, finish that part.